Okay, this is just a quick video on C4 polynomial inequalities, just in case you need some extra help before the test on Friday. Okay, so we've got our polynomial here, and we want to know when is it greater than or equal to 0. So the steps you would take would be you want to eventually graph it. First, we want to factor it using long or synthetic division. So I'm going to go through synthetic in this video too. So essentially we want to put it in factored form. Step 2, we want to find the roots. Step 3, we want to figure out our end conditions so that we can graph it. So all of this stuff is going to help us just so we can graph the polynomial function. And finally, step 4, we want to when is our function going to be whatever, greater than or equal to 0, or whatever the question's asking us to do. So that's what we want to do. So first I'm going to put this into factored form. So I need to find a root before I can synthetic it. So remember, I look at this number and I think of all the factors of 2. So I can do plus or minus 1 or plus or minus 2. One of those should work. So I just go through and I try it. So I say, okay, what if I subbed in a 1? Then I get 1 cubed plus 2 times 1 minus 2. I feel like that works. All right, so I know 1. So I just tried it and I found 1 is my root. So when I do synthetic division, I put that root there. Then I put the coefficients in front of each term. 1, 2, -1, -2. So 1, 2, -1, -2. And then I always bring down that first coefficient into that spot. And then I multiply this number out here by this number down here. So 1 times 1 is 1. And then I add my columns together. So 2 plus 1 is 3. And then I go through the steps again. 1 times 3 is 3. Then I add my column. So -1 plus 3 is 2. And then I multiply. 1 times 2 is 2. And then I add my column. -2 plus 2 is 0. This final number here is our remainder, so we always want that to be 0. Chosen the correct root, it always should be 0. Alright, so now I'm going to say what I had. This is what I started with, but I factored out this. So what that looks like in a bracket would be x minus 1, because positive 1 would actually be the root. And then what these numbers tell us are they tell us the coefficient in front of the x's. So I'm going to have an x squared, because I did start with the cubed, but I factored one of them out. So now I've got an x squared plus 3x plus 2 is greater than or equal to 0. And then I want to take it to fully factored form. So next I want to factor this. It's just a simple trinomial, so two numbers that multiply to 2 and add to 3, which would be x plus 2 and x plus 1. Okay, so I've fully factored it. Now let's just state our end conditions, because we want to graph it. So for our end conditions, I know it's a third degree polynomial. It's got a positive leading coefficient. So I know my end conditions are Q1, Q3. So let's give it a rough sketch here. 1, 2, 3. Okay. So I'm going to graph it. So my roots are x equals 1, x equals -2, and x equals -1. So I'm going to graph those. So I got -1, -2, and +1. And my end conditions are here, Q1 and Q3. So I have no idea. I didn't bother checking my y-intercept or anything. I don't know what these max and mins are, but I don't really care. I just want to know my shape of the graph. And now I want to highlight the values that are greater than or equal to 0. So we're talking about this as being our 0 line. So greater than is going to be above that line. So this section of the graph is greater than or equal to 0. And so is this hump right here, greater than or equal to 0. So to describe it, I'm going to use the inequality signs. So I want to say when it's right in between -1, -2, it's going to be positive. So how I would say that is like this. So that's saying when x is greater than or equal to -2 and less than or equal to 1, I know my function will be positive. And also pretty much anywhere 1 and later, like 1 and bigger, it's going to be positive. So when x is greater than or equal to 1. So all of these values here are going to make my function, or when my function is greater than or equal to 0. So this right here would be my actual answer. So C4 is pretty much just about that. So it has like aspects of C1 and C3. I could also give you the question in factored form, which would make it a little easier. Something like x plus 3 squared, x minus 1, maybe I'll throw an x out front, is less than 0. So I want to know when is that true. So I don't need to factor it because I already did that for you. I'll just find the roots, which are 0. I have a double root at -3, a double root, and 1. And I know it's a 4th degree polynomial because I have 1, 2, 3, 4, since that's squared. 4th degree, and I have a positive leading coefficient, so I know my end conditions are Q2, Q1. Okay, so make my graph. Alright, so I got a root at 0, a double root at -3, and a root at 1. And my end conditions are Q1 and Q2. So it's looking like, oh, I forgot I had a double root. Redo. Sorry about that. Okay, so I got a double root at -3, which means it's just going to touch that and then go back up. Totally forgot. So yeah, it looks something like that. I just kind of missed my root there. Okay, so I want to tell you when the graph is less than or equal to 0. So that actually looks like a pretty easy one here. It's just right there. So if I just had to describe that section, I would say it's between 0 and 1. So I would just do this, put x, and oh, I don't need the equal to sign. So it's when x is greater than 0 and less than 1. And that's it. And that's, yeah, pretty much all of C4. Okay, the end.